Welcome back to another episode of Chaos Theory. I'm your host, Rahul, and today we're delving into the fascinating topic of the Wallace Line, a significant concept in the realm of biogeography. So, grab your headphones and let's dive in. To kick things off, let's talk about what exactly the Wallace Line is. Imagine a boundary that divides two distinct regions of plant and animal species. That's the Wallace Line. Proposed by the brilliant 19th century British naturalist Alfred Russel Wallace, this line separates the species of Asian origin from those of Australian origin. It's more than just a line on the map, it's a crucial indicator of how geographical barriers and historical events shape the distribution of life on our planet. But what do we mean when we say biogeographic boundary? Well, it's all about the distribution of species across different geographical areas. Picture the Earth as a tapestry, with each thread representing a unique set of plants and animals. Biogeographic boundaries are seams between these threads, where one set of species ends and another begins. Factors like climate, geography, and isolation play a pivotal role in defining these boundaries. They give us insights into how species adapt to their environment over time. Speaking of adaptation, let's talk about the geographical distribution of animals. It's like a puzzle. Species are spread across the globe, fitting into specific niches that suits their need. The distribution is shaped by everything from climate patterns to physical barriers. Take penguin and polar bear for instance. They have perfectly adapted to their cold environments, but they have never met because they live on opposite sides of the world. That's the magic of geographical distribution. Now let's dive into the scientific reasoning behind the movement of tectonic plates and how it relates to the Wallace line. Tectonic plates are massive rigid sections of the Earth's crust that float on the semi-fluid asthenosphere beneath them. These plates move due to the convective currents in the mantle beneath them. Over millions of years, this movement has caused continents to drift and shift. In the case of Wallace Line, the movement of tectonic plates have played a pivotal role. The line itself runs through the Indonesian archipelago, and the deep sea trench to the east of the line is a significant geological feature. This trench is a part of a boundary between the Eurasian plate and the Australian plate. The collision between these plates, combined with the volcanic activity and uplift, has shaped the islands and land masses in the region. This geological activity has also contributed to the differentiation of species on the either side of the Wallace Line. The relationship between tectonic plates and biogeographical boundaries is truly fascinating. The movement of tectonic plates creates physical barriers that isolate species, leading to unique evolutionary paths. The geological history of a region shaped by plate movements influences everything from climate to habitat availability, which in turn affects the evolution of the species. And that's how the movement of tectonic plates ties into the Wallace Line. It's a reminder of how interconnected our planet's processes are, from the movement of continents to the distribution of life itself. But it's not just a tectonic activity that shapes the biological present. Ancient ecological events also play a crucial role. Natural occurrences like ice ages, sea level fluctuations, and volcanic eruptions have had a profound impact on the distribution and evolution of species. These events can lead to habitat changes, extinctions, and the isolation of population, all of which leave long-lasting impressions in the biogeographical of regions. Now, let's delve deeper into the specific aspect related to the Wallace Line, the region known as the Wallacea. Wallacea is a transitional zone located between the islands of Southeast Asia and Australia. It's a hotspot of biodiversity where species from both sides of the Wallace Line meet and interact. The unique mix of species in Wallacea reflects its position as a bridge between two biogeographic regions. This region further underscores the significance of Wallace Line as a boundary that shapes the distribution of life across our planet. Now, you might be wondering why migration didn't happen between these two continents, despite their proximity. There are several factors at play. The deep sea trench associated with the Wallace Line created a significant barrier for many terrestrial and freshwater species. Sorry, my bad. Additionally, different ecological conditions and environmental adaptations on either side of the Wallace Line could have discouraged migration. The geographical history or the geological history and timing of these events are complex, and understanding them helps us appreciate the intricacies of the Earth's biodiversity. Now let's wrap up by listing the different biogeographical regions across the world. These regions are like chapters in a book, each with its own unique set of characters that are the species, which call them their home. Here they are: the Nearctic region in North America, Mexico, and Greenland; the Palearctic region in Europe, Asia, which is excluding the Indian subcontinent, and the Northern Africa; Neotropical region, which is the Central and South America plus the Caribbeans; Afrotropical region, which is the Sub-Saharan Africa; Oriental region, the South and the Southeast Asia, which includes the Indian subcontinent; and the Australasian region, which includes Australia, New Zealand, New Guinea, and the nearby islands; and finally, the Antarctic region, which, as the name suggests, it includes Antarctica, and the other surrounding southern oceans. And that brings us to the end of today's episode. We have journeyed through the concept of Wallace Line, explored the intricate web of biogeographical boundaries, marveled at the way animals are distributed across our planet, and uncovered the geographical forces and ancient ecological events behind it all. I hope you have enjoyed this exploration as much as I have. Thanks for tuning in the episode of Biogeography Unveiled. If you want to learn more about the wonders of our planet, stay subscribed and stay curious. Until next time.